Hey there, grade sevens. So today we're going to be talking about outliers and their effect on the mean. So what I did is I was imagining that if I have 10 people that come into my class, I'm going to record their age and we're going to see kind of what happens. So here we have our data. So we have someone who was 11, 11, 11. We had 1, 2, 3, 4, 5 people that were 12. We had one person that was 13. And then I was obviously there, so I counted 2, and I'm 73 years old. So what's happening here? Well, we have a whole bunch of data that's very close to each other. So they're very, very similar. The numbers we have a range of 2, and then suddenly we've got this number that doesn't seem to fit with the rest, right? Obviously, as the teacher, I wouldn't fit with the students, so my age is completely different. Now, that would be what we would consider an outlier. So an outlier is something that lies outside of the regular data. So as you're working through your lessons, you need to think about what doesn't fit. Okay, what doesn't fit? Well, 73 doesn't fit with 11s, 12s, and 13s. If we go and we actually calculate the mean, median, and mode, well, let's see what happens. So we have our mean, we have our mode, we have our median, and then our range as well, because that's also going to be affected. So if we take the data that we have, our mean, if we add everything up, we end up getting 179, and then we divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives us 17.9 is our average age, which when you look at it, that doesn't seem right. Our mode is 12, our median, so it'll be 12, and our range in this case is 62, so 73 minus 11. That becomes our range. Now, what if we were to eliminate the outlier? Okay, how is this going to impact it? So if I didn't count my age and I only said, I'm only going to do students that walk in. Well, this is going to change because now we have 9 pieces of data. Actually, I'll leave that. No, I'll do it on the side. So my new sum becomes 106 divided by 9. So that actually gives me 11.7 repeating. Okay, so that's completely different. 11.7 compared to 17.9. Very different. My mode stays the same, 12. My median is also going to be 12, but now my range becomes 2. So you can see how an outlier can drastically impact your measures of central tendency when you have something significant that comes into play. So that's kind of the breakdown of an outlier. And an outlier can be on both sides. So you can actually have multiple outliers. All right. So say I gave a test and we had someone who didn't study and they got 3% on the test. Everyone else studied, but it was a hard test. So some of the scores included like 60%, 63%, 64, 68, 72, 76, and then 98. All right. So let's see that these were all of our scores that we had in the example, okay, on the test. We would actually have 2 outliers, okay? Our outliers, 98 doesn't really fit with the rest of the data, and 3 doesn't really fit with the rest of the data. So if we were to eliminate those pieces of information, it would change our mean, median, and mode. It would change our mean for sure. It definitely changes our range. And then it would possibly have an impact on some other stuff. We don't have a mode in this case. All the numbers are the same or occur the same amount of times. And our median, 1, 2, 3, 4, 5, 6, would be in between 64 and 68. So halfway through that is 66. So that becomes our median. Our range before we pull out the outliers is 95. And after we put the outliers or take the outliers out, our range becomes 16. So that seems a little bit more reasonable. So you guys can actually go and you can calculate what the mean is with the outliers and then without the outliers. All right, so you can feel free to pause the video or just try it as you go. I didn't do this beforehand, but I can. I've got a little calculator here. So our mean, when we have 1, 2, 3, 4, 5, 6, 7, 8. So whatever our sum is going to be added to 8. So we have 3 plus 60 plus 63 plus 64 plus 68 plus 72, 76, and 98. And we get 504. So we divide that by 8, and our average becomes 63. But if we remove our outliers, okay, so if we get rid of those, now we only have 6 numbers. So we get 60 plus 63 plus 64 plus 68 plus 72 plus 76. And then we get 403. Divide that by 6. And we get 67% as our average. So when we look at these two, we're thinking that our mean should be somewhere in the middle, okay? Would 63 represent kind of the middle of all the data? Well, with your outliers, yes, because we have a really, really low number that's bringing the average down, okay? But when we take out the outliers, 67% would be a lot closer to our median, which we said was 66. So that seems to make a lot more sense. And the measures of central tendency seem to match up a little bit better. All right. If you have questions, make sure you bring your questions to our Zoom session that we have. Make sure you do the Google form and the math makes sense. And then you're also going to have a second lesson to do today as well. So make sure you watch the second video that goes along with it. Have a good day.